Okay. Good evening all. Good evening. You are welcome to Tutorials with Family Talented Schoolboy. Today, we'll take a look at chemistry. And we are still on the topic, separation techniques. In our last class, we discussed crystallization. We also discussed sublimation. We also discussed, what else did we discuss in our last class? What? Distillation, fractional distillation, simple and fractional. So today, we move on to the next separation techniques. Please give me another one based on the outline I gave you. The next one is what? We are done with crystallization, No, the outline. Is that in that order? Okay. Decantation. Let's. I was thinking that the fractional crystallization should come after simple crystallization. That's what I thought. I mean, fractional crystallization. No, we have not done fractional crystallization. We stopped at crystallization last time. Okay. Don't worry, let's continue. Let's go to decantation. Decantation is a separation technique, but it's not actually, it doesn't give what? Accurate what? Separation. Am I communicating? It doesn't really give what? Accurate separation. Decantation is used to separate insoluble solid from what? A liquid. Decantation is used to separate insoluble solid from where? A liquid. Now, one thing with decantation is that, as I said before now, it doesn't really give accurate separation. You do decantation every day without even knowing. True of us. Maybe you want to go and bathe. There's water I fetched. After the water I fetched, as the tap was on, I didn't know that there's particles in the water. Until after fetching it, I covered the bucket, only for me to come and open the bucket again. I now realized that a lot of particles from, I don't know where they came from, have done what? Settled at the base of the bucket, the bottom. So what and I want to use water. What I want to do is what? To do what? To gradually pour what? The clear one. And most times, the other one enter. True of us, most times we do what? Unless you want to use small amount of water. If you truly want to use enough quantity, most times they will enter. They will do what? They will enter. So that's why I say that decantation is not a what? Is not that accurate. Am I communicating? But it can help you to, let's assume now you want to filter. You have a bucket of water filled with stones and other or bucket of water, or even a jar or what have you that has stones, particles you want to separate from. You want the water to come out. You know that you cannot go and start. Or if you put them in filter paper, they may tear the what? Filter paper. True of us. Unless you have a strong filtration medium. Unless you have a very strong filtration medium, that's when you can do it. If not, if you try to pour them inside, they will tear the what? So in that case, that you may use decantation to actually avoid those big ones. True of us. Then after that, you can now do what? Filter. Am I communicating? Then you know that the one as you are carrying a decantation, as you are separating them, it's only that small particles that will do what? Follow the water to enter the clean water to enter the jar you are using. Now after that, now you can now use filtration to do what? Clear the. Am I communicating? Clear the what? The particles. I mean, as much as it's true that it's not that perfect, but at least it can help you, prepare you for what else, what you want to, the next what is it called? Separation techniques that can give you the purity you are what? Looking for. Okay. So, as I said before now, it's used to separate what? A mixture of solid, insoluble solid from what? Water. Okay. It's very quick, as I said, but it's not accurate. Well, what is the next one? For let me understand what they're saying. We have what? Yes, you know, do you have this? Yes, I know. But first of all, it depends on the filter bed available, filtration medium you have, the volume you want to filter. Do you have what it takes to hold it? Am I communicating? These are things you do what? Consider. But if you want to, there are these some of the, you know, this one they used to say they used to prepare, process pap. I don't think it can allow such thing to pass through. I don't think so. Sand and water. You can use this thing. You can use first of all, use decantation. Am I communicating? Basically, sand. Water may not actually. Sand. You know, sand is dense. True of us. It will definitely settle. Sand, as in ray sand, will settle. Ray sand will do what? Settle. Am I communicating? Ray sand will do what? Settle. Or if you don't want to sacrifice the, what is it called? If you still want to recover the solvents, am I communicating? If you still want to recover the solvents, which is if you still want to recover the water, completely the exact volume the way it is, that means you have to do for process on how to do what, channel it, so you can get the actual list. But to get to a point that as you are decanting it, first of all, you remove the first set. See what you do. You can use if it's big. If the container that contains the water and sand is big, you now first of all you get a greater proportion of it and keep. Then pour the remaining one in a smaller container and keep decanting. Am I communicating? Because you don't want to lose the solvent. But it becomes a problem if there is all these light particles that easily float. That's where the issue lies. But if it's sand, as in sand, decantation can give what you're looking for. Because as you pour it, if you decant, the sand will not float. True of us, it will not float. As you pour it will just be. But the only thing is that because if the container is very big, as you are trying to let everything there go, they may follow it and enter. But let's assume you now pour in a smaller container, and as you are pouring in that smaller container, some of the sand will remain in the big container. Some of the sand will not go. Some will enter the smaller one. It's enough that if you allow that water to do what, to settle in the smaller, the sand to settle in the smaller one, you can easily do what, decant it. Okay, good.
Next is filtration.
Is that the next one?
So you talked about like I told even the one I told you, it's like one of my research. I got that a mixture of sand and water that separated with filtration. So that was why I asked.
No, see, filtration works better if it's dissolved. Am I completing?
It's not.
either dissolved or suspended. Sorry, not dissolved, suspended. If it's actually suspended, you know, sand. There's if you get powder now and pour in water, or any other solid that does not dissolve in water, it will form a suspension. Am I completing? It will wet and form a suspension. But sand sand will remain the way it is. Sand is, you can easily use decantation. But if you have a filter bed that can hold the sand, if you are using filter bed, if you have the filter medium, the normal filter medium we use here is not what is it called? Pepper. Unless I mentioned the cloth used, that I don't know what they call it. They use in that one can work if you tie it well in the empty container and then pour the water. It will gradually, that one can also serve too. Am I completing? That one can also what? Serve.
Okay, so you mentioned something like real sand.
If you say sand, people tend to misunderstand sand and soil and all those things. They're not the same thing. Soil has a lot of particles that are not even, some are organic matters, decayed organic matters and all those things. Sand is a compound. No, sand is a compound. Soil is a mixture. Sand is a compound. Soil can contain sand and other things, but that's why I say raised sand, as in sand itself. Sand is SiO now. It's SiO. Silicon what? Silicon what? It's another side of what? Silicon. So it's a compound. It's not a mixture. Sand is a compound. Now you talked about what? Filtration. Now let's go to what? Filtration. Let's go to what? Filtration. So basically, filtration is used to separate insoluble solid from where? A liquid. Remember I told you, if you want to get a good clearance, first decant before you do what? Filter. Can you remember that? I said it right? First decant before you what? Filter. If you want to have a good distance, decant, then you can now filter. Because as you decant, you have removed a lot of debris already. So the one you now filter is the one that are those small particles inside the what? The decant is what you now filter to remove it, to clear it. We call it clearance. To clear it, we call it clarification. To clear it what? Totally. Am I communicating? To clear it, we call it clarification. Clarification. We use the three separation techniques that are used for clarification are decantation, filtration, and what? What is it called? Centrifugation. Centrifugation. The decantation is less what is it called? Accurate than what? Filtration. Then the centrifugation will even separate more. Anyway, there's some higher way that you can use filtration. There's a filter medium. By the time you come up when you enter university at advanced level, you're going to realize that there are some bacteria you can filter. You can use filtration to filter what? Bacteria, depending on filter medium you are what? Using. So filtration is beyond this normal filter paper you use in lab. It's beyond that. Am I communicating? You can filter out bacteria. You can filter out bacteria depending on the what? The filter medium you are using. So let's go to filtration.
How can decantation be the separation of the solid from the liquid, and then filtration is the same? Okay, now what's the difference between filtration and decantation?
I think I don't I have explained this here now. I said that
Seems like both of them have like they work hand in hand.
yes, listen carefully. If you get the sand now, if you get sand and put in water, with sand, will it even wet? If not wet, true of us. Do you know what I mean by wetting? The reason that it will absorb the water and start becoming sticky or start changing its structure. Does sand do that? Sand will not do that. Am I communicating? But clay can do what? Can clay do that? Clay can do, but sand cannot do what? Do that. Sand will remain the way it is. True of us. Now, if you have a mixture of water and sand, you can decant that one because they can simple without issues. But get gari and put in water, leave it there. Come again, it will become what? It will absorb water now, but will it dissolve? You cannot use decantation in that one. True of us. You can't use decantation. Okay, it did not dissolve. Is it soluble? Sand is also not soluble, right? Gari is also not what? Soluble. But how come you cannot use decantation for gari? I don't know if I'm driving this home now. Uh-huh.
She understood what you said.
Okay.
But what she wants to verify from you is that because me, I've already studied both separation theory, so I summarized everything. Just listening to your addition to. So in my own this thing, when we were studying, I told her that in filtration, the separation of solids that have light density, like she said, after decantation is filtration. Because in my own there, decantation is separation of higher density. That during decantation, you are separating heavy like sand, and let me take it like sand now, real sand. Or let me take it like putting now.
The stone,
You separate first of all decantation, but they have high density.
Okay.
So there are small ones that have light density to use filtration.
Okay.
So it just the statement that I made over there that she wants to verify for me.
But I've said it now. Or is it because I
You don't mention it now.
okay, because I didn't mention this thing.
That's the difference between both of them. Because
What's that?
we read this we summarize it. Like you understand that both of them we are looking for. Even I wrote in my journal.
Okay.
Difference between filtration and decantation.
Okay.
Because both of them are slightly
Okay.
like the same.
Okay.
Now understand that depending on the one that have. So it's why reading both of them that understand that rice and water is separate with decantation, not filtration.
Okay.
All my thoughts has been filtration.
Do you know why you separate rice and water with decantation?
I don't know, but according
You know the
to
rice you're talking about is raw rice.
yes,
You
raw
can't
rice.
use cooked one. And raw one has
Which one is
density.
raw one?
Calm
Which
down,
one like
uncooked rice.
Eh.
Uncooked rice.
Put
What
in
are
the
you
shade.
doing? Calm down. You have to be specific with the rice. You have cooked rice. And cooked rice, this absorb water. If they cannot.
The point I'm making is listen carefully. I have explained everything
Yes.
here now. Listen carefully. I use gari and sand. Sand will remain, it cannot change. It will remain the way it is. You can decant it, but you cannot try with gari mixed with water. It can't work. Am I communicating? It cannot work. Now, when we say that a solid is something is insoluble in water, two things are involved. Yes, it's insoluble. Did it affect its integrity? Did water affect its integrity? That's one question. Carry sand and pour in water. About 20 years, the sand is like the way it is. Two of us, instead of it will shine, he said, the water will even wash it away. It will shine. Two of us, it will shine it. But get clay and put in water. You can't decant it. You can't decant it.
Because I did that was
Clay in water, you can't decant it now. Where will we start from?
I'm so but does
Yeah,
it
even
mean that
changing the
It will change. You can't decant it. It will change. It will change. It will change everything. It will blend, even though it will not dissolve, as in dissolving. It will change a lot of things. It will change the color. Where will it start from? You need a higher degree of qualification to separate them. You remember I told you that decantation, what is it called? Decantation, filtration, and they are clarification methods. They are what? We call them clarification. That one is a bit advanced anyway. They are called clarification methods. Decantation, just sand in water can easily be. Just as you say, raw rice can easily, unless you soak it for a long time. Am I communicating? But sand, no way. If you soak sand, where will you do water to? Even when you go sand, your man will go to all these things you see on the floor here. They're not sand. That one there. They're not sand now. Do you know what is sand? Do you know the one they bring from Tipaja? That one that is they bring from the side of the river, used to a mixing cement for building. That one, that is sand. That one is sand. This you are seeing here is a mixture of soil, sand, clay. This you are seeing here, that is not sand. Pour water, they will soak. They will do what? Soak. And if you want to decant them, if you as you even do that, they will follow. Where do you even start from? You want to decant, they will follow everything and enter. Boom. Even if you allow it to settle, and once you raise the thing, bam, they follow it back. That one, filtration can work. Filtration can do what? Work, but it will take time, okay? Because you having issues with that. Hey, I don't want to go into this. Let's not waste our time. If you having issues with what is called caking, the problem is having that's what is called caking. They will just be after it will get to a point. Those residues will block the filter medium. That no water will pass through again until you scrape it again, and they continue. You change this and it continue what filtering. I'm not concluding, but it will take time. Decantation is very fast. PM. Filtration takes that because they will drop it, bam, 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 until, but you get a clear solvent. That's where the name came from. Clarification, to clear. All right, let's by the time we go to certification, you understand better what I mean by clarification. You said the next one is what? Filtration. We are saying filtration, right? I think we have discussed it already.
Yes. Certification.
Where do we use filtration? We use in water purification, okay? Water purification plants and breweries. It's used in water purification plants and what? Breweries. Next one is what? Centrifugation. There's a machine we use for centrifugation. The name is what? Centrifuge. There's a machine we use for what? Centrifugation. The name is what? Centrifuge. And centrifuge, you know about your centrifugal force, right? Centrifugal and centripetal force in what? Physics. Okay, good. So the centrifuge has different test tubes are filled with. In fact, something like blood now. That thing, if you go to lab, you know blood is a mixture. Two of us, are you aware? It's a mixture of red blood cells, other things suspended in it. Now, if you use to separate plasma serum from what? Blood cells, you use what? Centrifugation. The blood sample we pour in will be they will put the blood sample in the tube, in small test tubes, and fix it into the water certification. It will roll like this for a long time. As it's rolling like this, after the action, there will be the sample will separate into two. The blood cells and other platelets, other things will be down, while the clear layer, upper layer is the what? Serum, right? Good. Now this is what. Now, as you can see, you know that filtration cannot do that well, and do it as fast as they need it in the lab. Am I communicating? How will you even start from infiltration? Where will you even start from? You get the blood and pour in filter bed and leave it and come back. So they need to because sometimes they maybe they want to do some carry out both some tests both on the blood cells and the what serum. They need to do what? Get the two layers. Okay. Now, so what happened is that of course I told you that it's a machine that used to do what? Carry out for centrifugation. It spin. You know what is spinning, right? To spin something, right? It spins at very high speed. At very high speed. Now, as it's spinning, you know that blood is a suspension. I hope you know. There's suspension particles. There's suspended particles there. There's also dissolved particles there. I hope you know. Now, and as it's spinning, you now have the heavier one will do what? Settle. While the lighter one will be what? On top of what? That one that settles composed of a lot of things. Red blood cell is there. Name them. There are many main things there. Now, when they are separated into two layers, you can easily do what? They can't. You can now do what? They can't. Remove the upper layer and carry the test you want to do what? Carry. They use it very well in our labs. These blood samples you they take from you and put in small distance. They carry. They use centrifuge very well in our lab, in the medical labs.
Is it only carrying out tests?
In lab.
This separation of quality the doctors want to carry out the test.
You want to study the samples for any purpose.
Okay.
For any purpose. The blood. I told you that the blood is a mixture, and whatever you want to do with the mixture, you know exactly what you want to do. Am I communicating? Whether it's the plasma protein you are interested in, or the red blood cells you are interested in. Am I communicating? So these things are will determine the one you use. Blood has a lot of things inside it, so it depends on what you actually want to do, the test you want to carry out. Of course, what else do they do in the lab apart from test? It's not test; they do in the lab. So the machine is called what? Centrifuge. Good. So I don't want to go into detail of what happens, the use of what is called blank. Those ones are deep, but I don't want to go there. So centrifugation is often used when you have small amount of material. It's often used when there's only small amount of what? Material. Maybe you just get small sample. Am I communicating? You can use what? Okay, now let's assume you just get. Are you aware that there's some blood sample that they get small distance? Hope you know. It will not be that depending on what they want to use it for. Now you cannot filter. You can't do what? Filter. Use what? Centrifugation to separate the two layers. Now, I think I mentioned it before. In hospital, blood samples are centrifuged to separate the blood cells from the what? Plasma. I think I mentioned it before. In the hospital, specifically in the lab, blood samples are do what? Centrifuged to separate what? Blood cells from where? From the plasma. Next one. Precipitation. From the name, precipitation. Okay, when do we use precipitation? Now, here they apply the knowledge of anyway, the knowledge I want to talk about came from the difference in the physical properties of this what material. Now, let's assume if you have a solution, if you have a solute inside a particular solution, inside a solution of a solute, and let me use a typical example now. If you know that water and ethanol are miscible, right? Right? Good. But iron 2 sulfate or so is not miscible with what? Ethanol. Are we together? Iron 2 sulfate, that is iron 2 tetra, also sulfate 6. Iron 2 sulfate is not miscible with what? Ethanol. But it's miscible with what? It cannot dissolve in what? Ethanol. But it is soluble in what? Water. Now, if you have a solution of iron 2 tetra, also sulfate 6 in water, and you want to truly remove iron 2 tetra, also sulfate 6 from that solution, it's simple. Just get a liquid that iron 2 tetra, also sulfate 6 is not soluble what? In. Once you pour the liquid, iron 2 sulfate is not soluble inside a solution of iron 2 sulfate. Iron sulfate will do what? Come out as a what? Precipitate. And if it comes out as a precipitate, you can filter. You can now do what? Filter and collect your what? Iron 2 what? Sulfate. Does it make sense? Now, and what will remain there is what will remain in the filtrate? What will remain in the filtrate is now what? Water and what? Ethanol. True of us. And how can you separate water and ethanol? Using what? We discussed this yesterday. Why are you looking at me like that? What? Water and ethanol. Simple distillation. With simple distillation, you can separate water and what? Let's assume you have one jar, a beaker that contains a solution. They mix. They get iron 2 tetraoxide of pieces, mix it to water to form a solution. Then you have another one that contains what? Or they may have three different beakers. This is practical now. We are talking about practical now. Yeah, if I have 3 different beakers, beaker A, beaker B, beaker C, and one contains this thing, iron 2 also sulfate 6 as a solid, right? And the other one contains water. The other one contains ethanol. And I ask you to mix ethanol, mix iron 2 sulfate and water. Then form the solution. Then separate the solution. What will you now do? If you filter, it cannot work. True of us. If you filter, it cannot work. So what will you do? You can simply do what? Once you introduce ethanol inside that solution, iron 2 sulfate do what? Form a precipitate. It will form a what? Precipitate. And if it comes out, you can now do what? You can do what? Filter. Now, so what happens is this: the Precipitation takes advantage of difference in solubility of a solid in two different what mixable what liquids. It takes advantage of difference in solubility of a solid in two different mixable what liquids, because the solid would dissolve in one, it will not dissolve in what the other. So if you dissolve in one and you want it to come out, simply do what? Pour the one, it is not soluble in. Once you pour it, to come out. These things are what the techniques used in your qualitative what analysis. Am I complete? Qualitative what analysis. That's one of my best part in chemistry when I was in secondary school. I enjoyed that thing. You say what? It takes advantage of this difference in what? Solubility of a solid in two different mixable liquids. In two different mixable what? Liquids. We'll give an example now. Using, and actually let me conclude. If you now add the liquid in which that solid is not soluble into a solution of that solid, the solid will do what? Come out as a what? Precipitate. You can now do what? Filter and recover the what? The solid. I give example of iron 2 tetraoxosulfate 6 FeSO4 and water and what? Ethanol. Ethanol and water are mixable. Iron 2 sulfate dissolves in water, but iron 2 sulfate does not dissolve in what? Ethanol. So if you dissolve iron 2 sulfate in water, you form a solution. And if you pour ethanol, iron 2 sulfate to do what? Come out as what? Precipitates. You can now do what? Filter it. So that's the basic thing that is they use how to use what? Precipitation.
Carry down to practical now. You know, we normally have color PPT.
Okay.
Yes, normally we used to have white PPT, that is colorless PPT, and we used to have colored black. So in a situation now, maybe the PPT is colored. Are you going to use filter? Would it have any? I don't think situation.
They are written against it. Okay, are you asking a question? Why not?
You use situation.
I know.
That color is.
Yeah, I know.
It's not going to have any
effect on what?
As in, it will be separated. As with the color, I'm talking about the French accent.
Who has the color? What has the color?
In our practicals, normally have color PPT.
Okay.
Normally have color, we used to have black PPT,
okay.
Pen. I'm asking those colored one apart from this colorless one.
Okay.
Can you also use filter? That's what I'm asking.
No. No, there's something you said. You say won't you stopped. You said won't you do something, you stopped. Why did you stop? Continue what you wanted to say. See what happens. See. So far, the color belongs, if the color belongs to the component that forms the precipitate, it will not pass through. It will remain as residue. What you see, it will clear liquid. But if the color belongs to any component that is soluble, it will pass through because you cannot separate it. So if blue, let's assume the thing is blue, and after falling, if the precipitate belongs to it, blue, that blue, haven't you seen that you filter a blue precipitate? Do you see the blue coming out? in your practical?
No.
Do you know why? Because if blue enter, what it means that the thing is not some enter the what? Filtrate. Three of us. You know, these things are molecules, particles, ions, as case may be, right? For salt.
Maybe on meeting, something like using maybe it's your test field now, maybe your practical now on meeting, change this color, and you know that it is going to be hot.
Okay.
Does hotness, the change in temperature, affect it also, or to also filter?
No, I don't. Try to. You don't always need to filter immediately.
Okay, don't need to. But it's going to this PPT method now can be used to separate it even on meeting.
Yes, now. But you know that if most PPT, if you hit, they will do what? Most PPT, if you hit, they will do what?
They normally dissolve, so don't dissolve.
Majority dissolves. We are taking the class to quantitative analysis. Ask the question. What and what? Air. Clay. Okay. Distillation. No, distillation is used for miscible liquids. Miscible liquids that have the difference in their what? The difference in boiling water. They have wide difference in what? Boiling point. When you do what? Okay. Do you know why you will not use it? There may be that thing you are hitting. You don't know what else that may be there that may even come out. Am I going to come out? You don't know what else, because that mixture, once there is solid particle, they don't use distillation. Okay? Just simply use, first of all, try to do what? Remove that what? Solid. I don't know if you understand. If you are asking if you have a mixture of solid and liquid, right? Clay is solid now, and liquid, whether you can use distillation. No, it's not. Huh? Yes. I thought I mentioned it here. Use what? Filtration. You use filtration. Is it clear? Now, what's the next one? I think we jumped. If fractional crystallization is still there, fractional crystallization.
Yes, sir, we have done that. I think last time we defined distillation. So I asked two questions. You say that what you define distillation.
I say fractional crystallization. It's not distillation I'm talking about. Give them many sources. Fractional crystallization. Aloma. Give them sources. Which area we are? Which area we are? All right. Let's go. Fractional what? Actually, if you're not careful, you may mistake it for ordinary crystallization. But what happens here is that in a particular solution. Am I communicating? In a particular solution, there may be more than one solute. That's one basic thing you should note. There are more than one solute. Now, and if you want to really, and that solute, this solute are, of course, one is here crystallization. That means they are not stable to what? Heat, right? Remember. Now, if you heat it a bit, as you do in what crystallization, then you start cooling. As you are cooling, you know there are some solute that they are soluble at a particular temperature, and they get insoluble at a particular temperature, because solubility affect temperature affect solubility. Hope you know. Do you agree with me? Good. Now, if the two of them they will have a kind of, their solubility should differ in different temperature. That's basic thing for you to be able to apply fractional crystallization. The components should have solubility. Their solubility should differ at different temperature. Now, if you heat and allow to cool, as you are cooling, it will get to a temperature where the one that may not be able to remain soluble at a particular temperature. When it gets to its temperature, as you are cooling, it will do crystallize out. Am I communicating? Then this is what we'll be doing until all of them crystallize out of the solution. That's one thing. This thing is not exactly the same thing with crystallization, neither is it exactly the same thing with precipitation, but it can be confusing if you are not careful. They can be confusing. They can confuse you. Just know that once you hear fractional, that means there's more than one solute in that mixture. Am I communicating? And if you cool, as you cool, if you go to a particular temperature at which any of them cannot remain soluble, it will do crystallize out. And as you cool, when you get to where the other one will not be remain soluble, it will do crystallize out. Am I communicating? This, if you understand fractional distillation. Fractional distillation is more like opposite of fractional crystallization. Are you aware? Watch out. In fractional distillation, as you heat, when you get to a temperature at which this one will turn to vapor, it will go. You do collect it, right? As you heat again, the temperature will be increasing. You get another temperature where this one will turn to vapor, it will do separate it. Now the same thing when you go to crystallization, you also use their solubility. As you cool, the solubility, when you get to temperature where the other one cannot remain soluble in solution, it will do crystallize. The only difference between the two of them is that fractional distillation use difference in boiling points at different temperature, while fractional crystallization make use of difference in solubility at different temperature. That's the only difference between fractional crystallization and fractional distillation. I repeat myself, the only difference between fractional crystallization and fractional distillation is that fractional crystallization make use of solubility, the difference in solubility, and is opposite of fractional distillation, because fractional distillation is that you are heating, true of us, but in fractional crystallization you are doing cooling. So as you cool, fractional crystallization make use of difference in solubility at a particular at different temperature, while fractional distillation make use of difference in their boiling, but their boiling point are very remember their boiling point should be very close. Am I communicating? Their boiling point should be very close. Their boiling point should be very close. Just as the boiling point is very close in the fractional distillation, when you come to fractional crystallization, the amount of the solute, the two solutes in the solution, they are roughly the same amounts. Close. The amount is almost the same thing, but not the same thing, but just close. The quantity of each of these solutes are what? Close. Am I communicating here? Just as you have, but when you go to fractional distillation, you talk of what? The closeness of their what? Boiling what? Point. So these things are just salient points that differentiate fractional crystallization and what? And of course, in fractional crystallization talks about solute and what? Liquid, right? Solute and solvent, right? Good. Now let's continue. What's time? 6:10. What is the next one? Use of what? Separating funnel. After that, what is the next one? Is that the last one? Flotation. Okay, let me talk about. Of course, we have. I think we have talked about. It's used to separate what? Immiscible liquid. Simple. Oil and what? Water. Kerosene and what? Once use separating funnel, they can simply go their separate what? Way. They don't have any business together. Okay, we are just forcing them to stay together. They don't have business what together, so they go their what? Separate what? Ways. So petrol and water do not mix together to form a single. Petrol and water do not mix together to form a single liquid. Do you know why? They are non-polar and polar what? Solvent, right? Hope you know. Petrol is non-polar, water is what? Polar. So there's no dipole there. Nothing will happen to them. They cannot mix. Water cannot wet petrol. Okay? It cannot. We call it solvation. Water cannot solvate what? Molecules of what? Petrol. It cannot happen because that water is be dipole, but polar. Water is polar. It has dipole. The other pole, but petrol is not polar. So there's no dipole, whatever there. It can't work. So water cannot wet what? Petrol. So that's why they cannot mix what? Together. So if you want to separate them, simply do what? Use a separating what? Funnel. And with that, the one that is less dense will do what? Go. The one that is dense will do what? Remain in the what? Funnel. Am I communicating? Alright, so flotation. What is flotation all about? Flotation, what is it all about? Any idea? Any idea? Any idea? Flotation, what is it all about? Gendix na haggo. So we don't take this. Oya favor. Talk to us about flotation. It's Nigia Gugu. Oya. Tell us about flotation. Let's tap in your wealth of knowledge. Say what you want to say. Say it. What is it all about?
I said that is this for the separation of a mixture of two solids in which one constituent is light and the other is vapor.
Also.
Example: mixture of white sand and then this to separate two solids now in which one is light and the other is heavy.
Who can see this? Okay, you are the helper. Gift. Are you with us? Are you sure? Gift doesn't like asking people that. I don't know why. Hey, Gift, why do you do that? Right, because you say you don't know, and I know you know it. You don't want to answer. Why? And Gift. It's not true. You know it. I don't believe you know it. You don't want to answer, and it's not good. We have what? Talk about it and let's hear you. With what? Okay. So how is it carried out? Who? Who's explaining? No, we are the professor of separation techniques. Oh yeah. Oh yeah, talk to us about that fast. Huh? Okay, oh yeah, now. Okay. Okay, now listen. Listen, as you say, flotation is used to separate what? You know that in particular, if you go to where they do extraction of metals, am I communicating? From their ore. You know, if you now get the ore, it's not just the metal alone. Hope you know. There are other impurities. That those things you don't need. True of us? Good. They constitute the what? Impurity. So you use what? Flotation to do what? To do that. Now what happens is this. You get a particular ore. Okay? Are we together? Just as you know, when we discussed what is it called again? When we discussed what is it called? Crystallization. We talked about seeding, right? Seeding, right? You get the what? That solute you want to do what? To come and get the seed and put it, and it will help you to do what? To crystallize what out. Now here again, what happens here again is that you use the low grade ore, the ore you are interested in. You get a low grade ore. Am I do it in form of what? Fine what? Powder. Am I communicating? Then having done that, you then mix it with water and air. You mix it with what? Water, what? And air. After mixing it with water and air, of course, you know that once you mix it once air enter, bubble enter. Hope you know. True of us, water, air, bubble enter. True of us. Now it will become foamy. Am I communicating? It will become what? Foamy. That foamy mixture is what you call what? There's a name you called it before. Fervor. There's a name you called before. There's something you said. You called a name that captured my interest. That's why I say you should continue. There's something you call. You say fruity something.
Flotation or frustration.
Okay, no problem. So now I say that if you get the low grade ore, of the ore you are interested in, am I communicating? You put it into fine powder. Then mix it with what? Mix with what? What I say now? I thought you guys we are writing it. Mix with what? Say it, Chioma. As I was talking, people we are busy. Oh, then what were you writing that time? When I was talking. When I was explaining flotation method, you were writing something. So what were you writing?
It's not in that frustration. The point I got from you is not that.
Oh, how are we talking? You are writing something else.
It's point now. Means a point.
About what?
Under crystallization before you divert into float.
No, I told you something. I wanted to borrow an idea from.
There's an idea. There's a point you made like that.
It's okay. Now I say that you get this is used to remove impurities from what? Ore. Am I completing? You are interested in the particular ore. What you do is get the ore, low grade ore, that same ore, put it in what? In fine what? Nature. You know what is fine now? Fine, right? Then you mix it with what? Air and what? Water. Am I communicating? So when that thing is done, merely air air enters it, it will become what? Foamy. Am I communicating? It will become what? Foamy. That is what is called what? Frothy what? Mixture. Frothy what? Mixture. Frothy. So when this is done, when this is done, you know, there are mixtures there. There are other impurities there. Now this frothy mixture will wet this some of these impurities like rocks, earth, rocks that is present as impurity. Rock can be an impurity there. Am I communicating? Rock can be an impurity there, and other components, and it will wet those things. And if they are wet, they will do what? They will do what? Settle. Instead of floating, they will do what? Settle. The only thing that will float is the what? Is the what? The impurity will do what? Settle. That what is it called? That ore will do what? Rise. Good. And when that thing happens, you now do what? The unwetted ore particles are carried to the what? Surface. Am I communicating? So when they are carried to the surface, you now do what? Filter them what? Off. You now filter them off. First of all, you know this thing is an oil. This is just a mixture. Impurity is there. The oil you are interested in is there also there, and other impurities. Just get that particular oil, but low grade. You know what you mean by low grade? By low grade, you mean that you know that you can't compare it to what you have inside there. Am I communicating? Am I communicating? Now, that's why I mentioned seeding. The way you put seed in the solution, and I will help the crystal to do what come out. The same way now, that's what is called. That's fine, the one you put in fine form, the ore, but you mix it with what? Water and do what? And air. And if you mix it, it will become foamy. We call it frothy what? Mixture. Now this foamy, if you now introduce this, see what will happen. If you introduce this, naturally the ore will do what? Come up. Am I communicating? Why the other impurities will be wetted by that thing, by the frothy mixture, they go that settle down, and that one that is suspended or floats. That's where the name flotation came from. That one that floats will now be what? Filtered what? Off, and use that is the oil you are what? Looking for. Am I communicating? Good, because you know these other impurities will be wetted by the what? The frothy what? Mixture. It will be wetted by the what? Frothy mixture. Why the oil you are looking for will be what? Up. Now this is those that are in extraction, work in extraction of metals. Maybe when we go to metal and their compound, we may say one or two things, especially at the introduction of each of these metals, how they are extracted. We may say one or two things about this flotation in detail, okay? So you on your own, you can also Google it and get more information on what flotation. But this is the basic principle. This is not detail, I hope you know. Just the basic principle behind it, behind what? Flotation at this level. There are a lot of processes involved. Not just this is just a kind of a skeletal representation of what actually what happens. Do you know if you work in oil company tomorrow? Now the last one is what? The time is 6:24. This one is a lot of things. There are a lot of things we will say here, but just know that the basic thing is that chromatography takes advantage of migration. The rate of migration of the what? It takes advantage of what? The rate of the what? Migration of the what? Solute from their what? Solution. So you can actually separate. You can use chromatography to do what? Separate solute from a what? Solution. You can use chromatography to separate solute from a what? Solution. Are we together? You can use it to separate solute from what? Solutions. Okay. Should we talk about it or should we leave it next time? What do you say? Next time. Next time. Raise your hand. Only you did. All of you, next time have it. We'll stop about today. We'll continue next time, as you said. That is next week, Tuesday. Please, if you don't have the new timetable, please copy it. If you don't have it, copy it. Do you have it? Please, no. Of course, no lesson tomorrow. Please, we'll see on Thursday. Thursday is what? On Thursday, we will review our chemistry. We'll do our chemistry review and do what? Is it English? Are you sure? Yes, it's English. All right, see you Thursday. God bless you.